AISL, October 2024. Time 1, Paper 2. Question 1. P is at 2, 2. The perpendicular bisector of PQ is y equals 4. Part A. Find Q. We just need to draw a line perpendicular to this bisector with the same distance from the line, that is Q. We need to find the midpoint of RS, so we take the average of the x coordinates and y coordinates of R and S. Then we need to find the equation of the bisector of RS. So we try to find the slope of RS first. Then we take the negative reciprocal of that. We can get the slope of the bisector. Since the bisector also passes through the midpoint of RS, we can substitute the point into the equation to find the y-intercept. D. We need to use Lear's labor interpolation to find the average time for the point 6, 8. The point is in the region of Q, therefore the average time is just 4. Then we do a t-test to determine if customers spend more money on weekends. The new hypothesis is the mean amount of money spent on weekdays and weekends are the same. So the alternative hypothesis is weekdays money spent mu1 is smaller than that on weekends mu2. The owner just takes 2 weekdays and 1 weekend as he likes, but not all the weekdays and weekends. So just a convenient sampling. Therefore, it cannot represent the population actually. Final part. The p-value is 0.0897, which is greater than the other, 0.05. So we cannot reject the new hypothesis. Question 2. The lowest point is 8 and the highest point is 45. We need to show the radius of the wheel is 18.5. So we just take the difference of the highest and lowest points, then divide by 2. Second part. Circumference is just 2 pi r. Part B. The wheel rotates 10 degrees. The distance of the pod travel is just the circumference times the ratio of 10 degrees over 360 degrees. The height is modeled by the function h here. T is the time in minutes. If the wheel takes 50 minutes for one revolution, B is the ratio of 360 degrees to 1 period, 50 minutes. So 24. D is just the height of the mid-level of the wheel, which is just the average of the highest and lowest points. Putting everything back to the function, we have the answer. Part D. Find T when h is 33. So we just set the function to be 33 and solve it. Beware of the domain of T and find all the solutions. Part E. Find the total number of revolutions. We find the revolution per hour first, and then we multiply it by 8, as each day it just rotates for 8 hours. Then multiply it by 3,000 days. Question 3. We have a table showing the rank and score of 10 countries. We need to find the upper quartile. First, arrange the score in ascending order. For 10 data, the upper quartile is the 8th data, so 7.2. Then, find the interquartile range. That is the upper quartile minus the lower quartile. And the lower quartile is the 3rd data, 6.5. So we get 0.7. Part B. So the Switzerland is not an outlier. We find the upper bound for the data first, which is the upper quartile plus 1.5 times the interquartile range. We have 8.25. The score of Switzerland 7.5 is smaller than that. Part C. We need to find A, B, and C. So we try to rank the score from high to low. We find that there are two scores 7.2. So we take the average of the next two numbers for ranks 3 and 4. Then A and C are also 3.5. The only number missing for the rank of the 10 countries is just 8, so B is 8. Part D. By calculator, we can get RS is just 0.164. And if France score is upgraded to 6.9, it is still ranked 6th, so no change. Part E. Shows that countries with high happiness scores are likely to be favorite expatriate countries. That is not appropriate, since RS is close to 0. Question 4. Calculate the shaded area by trapezoidal rule with 5 intervals. So the width is just 1 for every interval, and we just need to take half of the boundary values of y and add them to the other values of y altogether. Part B. Write down the interval represents the area. So it is the integration from 0 to 5 for the cubic function. And then we can get the answer 15.4. Part C. We need to write an equation in terms of R and H to show the information above. By considering the volume of the cylinder, we have pi r squared times h. Then make h to be the subject. Part D. Find k. We consider the surface area of the cylinder, and we have 2 pi r squared plus 2 pi rh. We try to substitute the h we find in part C into the equation. We can see that k is just 800. After that, we can find the derivative of a and set it to be 0. We can find the value of r which minimizes a. Finally, we can substitute r to find h, the height, and c, the circumference of the container. And we can see that which is much greater than the dimensions of the label, so the label will fit on the container. Question 5. We have a rectangular right premium tent. We try to find OT, the height of the tent. Just by Pythagoras theorem, we have OT equals 2.9394. We know the base of the tent is formed by 6 equilateral triangles. We try to find the area of the base. That is half AB sine C times 6 triangles. After that, we also need to find the volume, which is just 1/3 the base area times the height OT. Part C. We want to find the angle OAT. By cosine the angle equals adjacent sine over hypotenuse, we get 44.415 degrees. Then we have a new point Q, which is extend from the line AB. As we find angle TAB in part C, we know the angle QAP is 135 point something. Then we can also find angle QPA. After we find all the angles in the triangle, we can apply sine rule to set an equation to figure out AQ. Finally, we have a point R, which is on the line PQ, and AR is 0.8. So it is better for us to draw the triangle and mark point R on the diagram first. We can see that we have one angle and two sides, and we try to figure out the final line QR for the triangle. So we can apply cosine rule to form the equation. We see that it is actually a quadratic equation, so we can solve it by calculator.